Module 5, Configuring and Managing Virtual Networks. It is important to know that virtual machines need to be able to communicate with other virtual machines and with physical machines within your environment. Remote host management and IP-based storage must be able to operate effectively, and the failure to properly configure your ESXi networking can have very negative effects on the operations of your VMware environment or your virtual infrastructure. There are 2 lessons in this module: Introduction to vSphere Standard Switches and Configuring Standard Switches. We're going to go over Lesson 1, Introduction to vSphere Standard Switches. We're also going to discuss a little bit about distributed switches. Lesson 1, Introduction to vSphere Standard Switches. By the end of this lesson, you should be able to meet the following objectives: describe the virtual switch connection types, configure and view standard switch configurations, such as the virtual machine port group, the VM kernel port, VLANs, and security features. You should be able to list the features of the standard and the distributed switches and compare them. Types of virtual switch connections. Virtual switches provide the connectivity basically between virtual machines on the same host or on different hosts. And with that being said, virtual switches also support your VM kernel networking access for remote host management, vMotion, which is moving your virtual machines from host to host, iSCSI, and NFS. So what kind of connections does a virtual switch have? You got virtual machine port groups. You have your VM kernel port for IP storage, vSphere vMotion migration. You have your vSphere fault tolerance, vSAN, vSphere replication, and your ESXi management network, and you have your uplink ports. So on this slide, as it said, we have our uplink ports going right here, and every uplink port will basically connect into the virtual switch. Within that virtual switch, you can have your different port groups, which come over here in virtual machine port groups here. And as you'll notice, in this, basically this port groups here, you have 3 different ones. Your first one is production. Your second one is your test dev. And your third one is your DMZ. Now, within all of them, you go to another side of it, you can have a VM kernel port which would support your vMotion. It's where you move your virtual machines host to host. And you have your management of your entire ESXi network. So it's important to know that with this screen here, the ESXi management network port, which is here, is used to connect the network to remote services, which include your VPXD on the vSphere server and your VMware host client. Now, each ESXi host management network port has its own, and each VM kernel port must be configured with its own IP address, your network, and your gateway. And as you'll notice in the previous slides, we talked about setting up your networking. Well, that's where you want to just double check and you want to make sure, okay, do I have my IP address right? Do I have my gateway right? What network do I want to be on? So, with that being said, to help configure the virtual machines, or these virtual switches, as you see here, which is this entire, it's basically a replication of the virtual switch, you'll create those port groups. A port group is basically a template that stores the configuration information to create virtual switch ports. So this is your port group here. Well, within that port group, you have your ports, your switch ports on that virtual switch that basically give you access into the production, test dev, and your DMZ. Virtual machine port groups and VM kernel ports, they connect to the outside world through the physical Ethernet adapter which we said we got to have our, say this is our Ethernet adapter down here, right, which is our physical device. Well, we take that and we virtualize it, and that then gets virtualized in this virtual switch that allows everything across your VMware environment to talk amongst each other. All right, so when you go to configure your standard switches through your vSphere clients, so as you see on this slide right here, we're in the vSphere client up here up top, and we're on ESXi01. And what we want to do when we add our VM kernel adapter, you want to add your virtual switch here. We're going to select the connection type here on ESXi01. Once we select our connection type, you got two options: VM kernel network adapter, virtual machine port group for a standard switch. As per this slide here, we're going to look at the VM kernel network adapter. Once you get that set up, you'll then select your target device, your port properties, your IP address settings, IPv4. Then it's going to have you ready to complete. Now, in previous slides, I also went over how VMware had it set up. It's like this mostly everything. As you configure your connection type, you go to the next option. Select your target device. Select your port properties. Well, if you go back and say, hey, I got my target device, I don't think it's right. Go back, folks. Go back. Check that target device. Look at it. That's why that's there, so it can help you manage and configure that vSphere standard switch correctly. So here's an example right here where basically when you're designing your network environment, vSphere enables you to basically put all your networks on a single virtual switch, okay? So as you see right here at the top side, which is this one right here, we have everything up here all on one virtual switch, right? Okay, but on the other side of it, you can opt to have multiple virtual switches, as you see down here. So we have our own virtual machine, we have our own virtual switch for management, vMotion, production, test dev, iSCSI. All right, now that depends on the layout of your physical network. So if your physical network will actually suffice you having different virtual switches and you have the network physical adapters to support it, that's fine. Just know you need to set up what is the correct way, what is best for my organization. An example might be you might not have enough network adapters to create that separate virtual switch for each network. But then again, your team you might have the network adapters on a single virtual switch that can isolate the networks by VLANs. So you see right here, this may be on a management VLAN, vMotion, production, test dev, iSCSI. So with that being said, because your physical NICs are assigned at the virtual switch level, all those ports and port groups are now defined for a particular switch that will share that same hardware. Okay, and then down here at the let's look at this again. So you see right down here we have, in this instance here, say we do have the physical devices to support each one of these. Well, if that works better in your organization, that's how you need to set it up. Then that would give you the option, okay, well I got my management, my vMotion, production, test dev, iSCSI, and you have 5 different virtual switches. Now at the top we have one virtual switch supporting your management, your vMotion, production, testing environment, development, iSCSI. All right, what about the components of a standard switch? A standard switch provides connections for virtual machines to communicate with one another, whether they're on the same host or different host. Now, this slide right here shows 5 standard switches. So where are our standard switches? We have 1, 2, 3, 4, 5. First thing to see right here, the standard switch, a standard switch with a single outbound adapter is is used only by VM1. Okay, so we have a single device adapter, and you'll notice that it only attaches here to VM1. Alright, the second instance. What does that second virtual switch do? Well, an internal only standard switch. This enables virtual machines in a single ESXi host to communicate directly with other virtual machines that are connected to the same standard switch. So you'll notice here VM2 and VM3 use that switch to communicate to each other. So we got right here to virtual switch 2. It comes up and you can have them going each way. So 2 can talk to 3, 3 can talk back to 2. What about switch number 3? Teamed NICs. Alright, here's what we're going to talk a little about. Here's what we're going to highlight, not really talk about. We're going to talk about NIC teaming. A NIC team provides automatic distribution of your packets and failover. And as you'll see, we have these 2 NICs right here teamed together on this virtual switch going to this virtual NIC for VM3. Let's look at switch number 4. This switch is used by the VM kernel to access any of your iSCSI, your NAS-based storage. So you see right here we have our one physical device going up to basically our IP storage on a virtual switch. So this is going to allow us in our NAS, our storage device. Storage. Right? Alright, what about the 5th standard switch? That's used by the VM kernel to give us remote management capabilities. So with them, as you see right here, all 5 of these standard switches, you got different use cases for them. What best works? As you see right here, this is our main switch. We got this switch broken out to virtual switches here, 1, 2, and 3, and 4, and 5. Well, in this first switch here, we got test VLAN, production VLAN. Well, as you'll notice, the test VLAN and the production VLAN come out to switch 1 going up to these NICs here. That's going to give us access to VM1, VM2, and VM3. VLAN 103, 104 go over here to the second environment with our NICs. And those environments basically go up and connect to 4 and 5, okay, which give us your IP storage and your management network. So let's look at the standard switch configuration. You can view a host standard switch configuration by basically clicking virtual switches on the configure tab. All right, so right here we have our host within our lab servers folder. Right here's our virtual switches. Virtual switch 0, and you'll notice we have virtual switch 1. So we have 2 different virtual switches within that host. Now what that is, vSwitch 0 is the standard switch on an ESXi host. By default, that installation creates that virtual machine port group named VM Network and a VM kernel port named Management Network. So you see right here we have our management network, we have our physical adapters coming in here, and we have our VM network here, and it automatically assigns your VM kernel ports. It's always good practice to remove the VM network virtual machine port group and keep virtual machine networks and your management network separate for security. They say kind of both for performance. I agree with that. Security. In today's time, security is huge right here. I think that's the best way to do it, is to keep them separate. To remove a standard switch, you want to click the red X, which is basically right here, to remove it. The port group properties for a port group can be displayed. So if you want to look at the port group properties, go right here. Look at your port group properties. What's in that port group? You're going to have labs where you're going to go through and you're going to view these switches. Go look at them. All right, let's talk about CDP, Cisco Discovery Protocol information. What does this do? Well, it enables administrators or ESXi administrators to determine which Cisco switch port is connected to the given virtual switch. So right here, which Cisco device is basically sort of Cisco switch port connected to that virtual switch, which is vSwitch 0. When CDP is enabled for that particular virtual switch, you can always view the properties of the Cisco switch from the VMware client, or the client as you see here, that include the device type. You got your port ID, any hardware capabilities, and anything about that virtual switch or the management network, which virtual machines are connected to it, and your physical adapter. VLANs. So ESXi supports 802.1q VLAN tagging. Virtual switch tagging is one of the tagging policies that are supported. And with that being said, VLANs provide for logical groupings of switch ports that enable the communications as if a virtual machine or the ports in the VLAN were all on this physical local area network segment or same network. A VLAN is a software configured broadcast domain, and by using a VLAN, it has great benefits such as creating logical networks. You get dramatic improved performance, or not dramatic, but drastically improved performance by confining the broadcast traffic to a certain subnet of a port of that switch. And you also have the cost savings by partitioning the network without the overhead of deploying any new routers that need to be in the network. So as we see here, you also notice that VLANs can be configured at the port group level. The ESXi host then provides the VLAN support through the virtual switch tagging. So we got down here, we're going up here to the virtual switch, and we got our VLANs. Well, where does it tag it at? That is provided by giving a port group to the VLAN ID, which is 105 and 106 here. But by default, the VLAN ID is optional. And when we say optional, the VM kernel takes care of all the tagging and the untagging of packets that will go through that virtual switch. What about the port on a physical switch? The port on the physical switch to which an ESXi host is connected, it must be defined as a static trunk port. So we see right here we have our static trunk port going to our physical switch, our physical NIC here, right? And that trunk port is a port on the physical Ethernet switch that has to be configured to send and receive the packets that are tagged with the VLAN IDs. No VLAN configuration is required in the virtual machine, and for that, the virtual machine does not know that it's connected to the VLAN. So what about your network adapter properties? The physical adapter can become a bottleneck for network traffic if the adapter speed does not match the application requirements. So as you see in this slide here, right here on this physical adapter, we can change the connection speed and the duplex of that physical adapter to be in compliance with the traffic rate. What rate of the traffic do you want to go across your network? Well, right here, you see we're in this ESXi host, in the physical adapter here. We're going to see right here, and you'll notice that we have 3 VMX Net3 virtual Ethernet controller. We have 4 NICs, 0, 1, 2, and 3. Well, if we want to change that duplex speed on VMNIC 0. We'll click the little pencil right here. Boom, go change it. What's best for your network? Types of virtual switches. All right, so we talked a little bit about standard switches. Standard switch is a virtual switch configuration for a single host. What about distributed switches? Distributed switches is a virtual switch that's configured for an entire data center for multiple hosts. Up to 2,000 hosts can be attached to the same distributed switch. And you have, with that, consistent configuration across all the attached hosts or the multiple hosts within your environment. Now, it's important to know that all the hosts must either have enterprise license or belong to a vSAN cluster as well. And both switch types are elastic, meaning that the ports are created and removed automatically. All right, distributed switch architecture. So as you see right here, vCenter server owns basically this configuration of the distributed switch. And you'll notice that this configuration is consistent across all the hosts that are going to use the distributed switch. Okay? So say we have host 1, host 2. We have our physical NICs with our uplinks, which are here, under the bottom. On the top side, we have our hidden virtual switches on the I/O plane that are virtualized. Well, what about that distributed switch control plane? All that is integrated, all this here is basically integrated, all in that distributed switch, and it's consistent across the entire switch. So your vCenter server here controls everything within that distributed switch to give you your distributed port groups, ports, and your uplink port groups to get to your management port, your vMotion, in which vMotion we can move different VMs from host to host. And then as you see on the other side here on this distributed switch, we have another set here that has our management port for this set of VMs here, and then we have our vMotion port. So let's compare your standard switch and your distributed switch. Layer 2 switch for both of them. VLAN segmentation. Both of them support IPv6, 802.1q tagging. Both of them can NIC teaming. And you have your outbound traffic shaping. Now the biggest thing to know with a distributed switch here is distributed switches allow you for inbound traffic shaping, VM network port block, your private VLANs. You can do load-based teaming. You have data center level management because it's all integrated basically in that one distributed switch, which you can see it all. So it gives you a broader view of managing that network over a distributed switch. You can vMotion migration over the network. So you can go from one host to host or multiple switches. You have per port policy settings. Port state monitoring. You can now monitor the state of that port. NetFlow, port mirroring. You should now be able to meet the following objectives. What is a virtual machine or a virtual switch? And describe the connection types. Configure and view standard switch configurations such as your VM port group, VM kernel port, VLAN, and the security features. And you should be able to list the features and compare the differences of a standard and distributed switch.